Morning everyone. Thank you all for joining us today for our first Leaders of Influence webinar series event. The electric vehicle future has arrived with Dr Jake Whitehead. It's fantastic to see such great interest in Jake's session. My name's Kai Williams and I'm the Deputy Director of Engagement and Philanthropy in the Faculty of Engineering, Architecture and Information and Technology at UQ, and I'll be helping Jake facilitate the session today. Okay, so let's get started. I'd now like to introduce our presenter for today, Dr Jake Whitehead. Jake holds 2 PhDs in Transport Science and Transport Engineering, in addition to a Master and Bachelor of Civil Engineering. His research career has focused on analysing the impact of government policies on and consumer preferences towards novel transport technologies, including shared, automated and electric vehicles. Jake works closely with many Australian governments to provide advice on sustainable transport policies. Jake's currently the inaugural Tritium E-Mobility Research Fellow at the UQ Dow Centre for Sustainable Engineering Innovation and is also a Research Fellow in the UQ School of Engineering. All right, I'd now like to hand over to Jake. Over to you, Jake.
Good morning, everyone. Welcome to the University of Queensland. My name's Jake Whitehead and I'm the Tritium E-Mobility Fellow. Thank you so much for joining us today. I'm really excited to host our first live webinar to talk about electric vehicles. As you can see, I'm surrounded by a number of different electric cars today. But before we jump into a tour, I just want to highlight that here at UQ, we are doing research right across the e-mobility spectrum. So that's everything from electric scooters and electric bikes to electric cars like we'll look at today, up to electric buses, trucks, and even potentially in the future, electric planes and ships. So whilst today we will very much focus on electric cars, if you do have any other questions about these other forms of e-mobility, please feel free to send them through and I'll do my best to answer them. So let's go take a look first at the Tesla Model 3. So here we have the new Tesla Model 3. It was introduced in the US a couple of years ago, but has only recently come to Australia towards the second half of last year. And so it's a little bit smaller than the other Teslas that you're familiar with. And it comes in 2 options, a standard variant, which is good for about 350 kilometers. It has a 50 kilowatt hour battery. And then here we have the long range or performance variant. And so it has a larger battery at about 75 kilowatt hours. And that's good for somewhere between 450 to 500 kilometers. So really starting to get reasonable in terms of those longer distance trips, as well as being a useful car for your daily trips around town. Now, the thing about electric cars, although it might not be immediately noticeable, because the drivetrain is so compact, it provides the car designers with a lot of flexibility with how they design the overall body of the vehicle. And so for a car this size, the wheelbase, which is basically the distance between your front and your rear axle, is a bit bigger than a normal petrol or diesel car of the same size. And what that means is that you get a more comfortable ride, but more importantly, you actually get more space in the cabin. And so that's really important because although sometimes from the outside, electric vehicles look a little bit smaller or a bit more compact, generally on the inside, they have much more storage and are pretty comfortable. So we'll take a little bit of a closer look at some of that storage in a moment. Now, with all electric vehicles, the name of the game is efficiency. It's all about trying to reduce the amount of energy that the vehicle uses in order to make it drive as far as possible. And so a lot of electric vehicles have employed different techniques to try and improve that efficiency. And part of that is reducing the drag of the vehicle. So you can see that with the Tesla, also similarly over here with the Hyundai Ioniq, they're quite sleek vehicles. And in addition to having quite sleek bodies, they employ a few, nifty tricks. So the first one, we'll look here at the handles. So you can see that the handles on the body of the car are actually flush, and this is how they open, just like so. And so it's, a minor factor, but it does reduce that drag. The other factor is with the wheels. Now, on this particular vehicle, it does have aftermarket wheels, so they're not as efficient. But when most electric cars are purchased, they come with quite flat wheels. So with my very good cutting skills, I've pre-prepared a hub here. But if you can imagine having a disc over this wheel, what happens is as the air travels around the front of the body, it doesn't get hit with all of the turbulence of this open wheel, and basically means that the car can move forward much smoother through the air and use less energy. It's actually quite a bit clearer to see over here on the Ioniq. This is the actual MAD wheel, and again you can see that it's a reasonably solid disc, which helps a lot with efficiency. What I've noticed is with the Tesla, going from having that solid disc to more open wheels like this is almost up to a 10% difference in the driving range. Now, you have to argue, if you've got 500 kilometers, maybe you don't mind that for the look, but certainly that's what car designers are trying to take into account in terms of making them as efficient as possible. So if you put your imagination caps on for a moment, and we were to peel off the body of this vehicle, essentially what you'd be left with is what's called the skateboard design. And so it's called that because you've got a front axle with an electric motor on there, a rear axle with another electric motor, and then you've got the battery, which is effectively the skateboard deck. And so it's positioned at the bottom of the vehicle because that's where there's quite a lot of weight. So that makes the vehicle much more stable. And it also means that that weight can help in terms of the overall structural rigidity of the frame, which means that they can reduce the weight in other components. And whether it be the Tesla we're looking at here today or other electric vehicles that are purpose-built from the beginning to be electric vehicles, they generally follow this skateboard trend. Now, if we come in close on this front wheel, you'll notice here that the car still has a normal caliper. So electric vehicles do have mechanical brakes, but they're used far less often compared to your petrol and diesel vehicles. And that's because these vehicles that are electric can actually use the motors as generators through what's called regenerative braking. And so whereas normally as you're traveling along in a car and you want to slow down, you apply the brakes, they clamp onto the disc or drum and slow you down. With an electric vehicle, the motor can actually capture that kinetic energy and turn it into electricity to provide charge back to the battery. And so that helps increase the driving range and in fact make the vehicle more efficient. And so that brings us to our first poll question for today's webinar. I'd be really interested to know what you think that regenerative braking can do in terms of extending the overall driving range of a vehicle. So I'll get Kyle to cue that poll question now. And whilst you're answering that, Kyle, how are we looking for questions?
Yeah, I've just launched that poll, Jake. A couple of questions that we've answered ourselves at the moment. Yeah, and the votes are coming in on the poll now. We'll just give it about 30 seconds for everyone to vote on their answer.
Yeah, so whilst that's happening, another feature to look at is this massive glass roof. So you'd actually notice on this car that the glass goes all the way from the front. Your first piece here is the windscreen. You've got another piece of glass, and then this quite large piece of glass that comes all the way to the back of the vehicle. And so one of the benefits by going to the glass is obviously it looks quite nice. You get that extra light in the vehicle, but you also get extra headroom. And again, if we think back to that skateboard design in terms of the batteries being along the bottom of the vehicle, what that means is that generally with electric vehicles, you sit a little bit higher. And so it's really important to maximize that headroom without having to extend the overall height of the vehicle, which would obviously then create more drag and make it less efficient. So again, that's another reason why we're seeing a lot of electric vehicles now incorporate these glass roofs. And, you know, I'm often asked, well, you know, what's the safety around that? Is that, you know, really going to be something that becomes the norm? The reality is that the testing on this glass in particular has been found to be able to support about 5 of these cars stacked on top. So it's extremely safe and strong. It's not like a normal plate glass where you would smash and it would shatter into a million pieces. It's laminated, and that gives it that really safe, strong structure. So, Kyle, going back to you on the poll.
Yep, poll results are in. So the 64% of people on the session voted for B, which is 5 to 15%.
Yeah, so we've got some whizzes on the line. I think you're spot on. So somewhere in that range of 5 to 15%. Often some people think, oh well, if I have regenerative braking, I must be able to get all the energy back. So if I drive up a hill and go down the other side, it'll cancel out. In reality, nothing is 100% efficient, and so even though you do gain some of that energy back going down the hill, and it's sure better than nothing, like you get in a petrol or diesel vehicle, it's not 100% efficient. But, particularly in city driving, where you're stopping and starting quite regularly, whether it be in a car or, importantly, when you start to think about electric buses and electric trucks, it can play quite an important role in improving that efficiency and extending that overall driving range.
Jake, we've just got a question come in. It's from Mark. He says the 10% loss of range from changing from the flat-faced wheels is quite staggering. Have the original wheels been put back on to verify this at all?
Yeah, so that's based on a comparison between having the original wheels on there and these wheels now. It hasn't been possible to put the original wheels back on, but we've been able to compare with some other models out there. I think, that 10% in part would also be affected by the tyre being a little bit bigger, but the actual cap in of itself, there's been a lot of testing where owners have been able to take the cap off and drive without it, and it found that kind of 5 to 10% happening. Of course, it really depends on the driving conditions and where you're going, but it can be quite significant, particularly in those higher speed environments where you've got a lot of air passing past the vehicle. If it is open like this, it creates a lot of turbulence. So we might now come around to the rear of the vehicle. And so immediately, one of the biggest things that you'll notice with an electric car compared to a conventional petrol diesel vehicle is there's no tailpipe, absolutely no tailpipe. So effectively, in terms of the actual vehicle driving along the road, there are no emissions. Now, that doesn't take into account the emissions of producing the vehicle and also the emissions created from the electricity. But purely in terms of driving around town, why a zero emission vehicle is really important is for public health. So quite often, it's not very well recognised that even in Australia, where we have beautiful clear skies and relatively clean air, there's still estimated to be more premature deaths from motor vehicle pollution compared to road vehicle accidents. It's about 1,200 on average per year versus 1,800 premature deaths from motor vehicle pollutions. It's a different type of death. It's an economic statistic, but nonetheless, it highlights how incredibly important it is that we think about electric vehicles far more broadly than just being a way to reduce greenhouse gas emissions, but take into account what the impact of those emissions are having on our health, on our children's health, and our parents' health. The other factor, though, is that if we take that broader view and take into consideration, well, there is electricity at the moment generated from fossil fuel, and so there's emissions associated with that. Even in Australia at the moment, with an electric vehicle, because the drivetrain is so efficient, you're still looking at somewhere between a 20 to 40% reduction in greenhouse gas emissions from that operation. So it's quite significant. And we know that as the emissions profile of the electricity grid continues to improve, so too will the overall emissions associated with electric vehicles reduce. But the interesting thing with this is that's if you look at this car as purely being just a car. And what's one of the really exciting projects that I'm currently working on here at UQ through a Advanced Queensland Industry Research Fellowship is essentially looking at electric vehicles as batteries on wheels. So trying to get an understanding that these vehicles are generally parked 90% of the time. Although we want them to have 300, 400, 500 kilometers of driving range, on average in Australia, the car's driven around 30 to 40 kilometres. So there's a massive buffer there for us to be able to leverage and potentially be able to support the grid by absorbing more renewable energy when the car's parked either during the day through solar or overnight with wind, and then potentially in the future be able to export energy from the vehicle to power the home and the wider grid. So we're doing some work in that space specifically to look at what the situation might look like in Queensland. And I hope in the near future we get to do another one of these sessions where we can go into a bit more detail about that.
Jake, we've just got another couple of questions, if you wouldn't mind. Questions from John. Do you think electric vehicles are more rugged than conventional vehicles? And if so, what are the components that make it so?
So more rugged than conventional vehicles. I guess if you mean by rugged, are they more robust in the sense that they have less parts that can fail? I would certainly agree with that. So the drivetrain is not only compact, but it has very low maintenance. We'll have a look under the bonnet in a second to see what's under there, but realistically, there's very little maintenance that's been required with electric vehicles. There's no oil changes. You don't need to be servicing cylinders and overhead cams and gearboxes. It's very much a closed system, which means those maintenance costs are quite low, and also the overall reliability is quite high. So they say that with the motors that are currently being equipped in electric vehicles, they could easily run for more than 1 million kilometres without any issues. And if you think about at your home, you don't have a petrol-powered kettle, you have an electric kettle. You don't have a petrol-powered TV, you have an electric TV. And why is that? It's because it's much more energy efficient, it's much cheaper, and it's much more reliable than the combustion engine. All right, let's jump in the boot. So what you can see here is that for a vehicle of this size, it does have a pretty decent boot, but it has a bit of a trick up its sleeve. And so if we look under here, we actually have even more space. And in fact, I've got my little mate in here, the electric drone that I thought I would bring along for us also to be able to talk about. In e-mobility, it comes in all different shapes and sizes, and we are starting to think about what this might mean in the future. We won't focus too much on that today, but it's certainly an exciting thing. But what I wanted to highlight is with that extra space there, it means that you can fit another, a couple of bags, and this is all made possible through the electric motor being so compact. So the electric motor actually sits a little bit in front of that, which frees up that space. And this is, just the example of the Tesla, but we're seeing this in many different electric vehicles that they can be able to unlock all this extra space, which previously would have been taken up, potentially with a fuel tank. Okay, so we'll now come back around the side of the vehicle and come to the topic that, I think is the most common thing that I'm always asked about, charging. So with this vehicle, the charge port actually sits behind this flap. So you can see here, this is the port. The top section is generally what's used for slower AC charging, or what that's called when you're charging at home. And those two larger pins at the bottom are what are used for those higher power charging rates. So today I've brought along this mobile connector. So it looks very much just like an oversized laptop adapter. At this end, you've got a plug that you can plug into any power point. And at this end, you plug it into the vehicle like so. Now, with this type of charger, it comes with every electric vehicle. It is the slowest way to charge a car. So you're probably looking at something around 15 kilometres per hour on average. But in an emergency or just for a little top up overnight when you're travelling around, it can be quite useful.
Now, Jake, while you're on the topic of batteries, I've got a question here from Simon. What is the lifespan of a battery, and do you need to service or maintain it?
So, very, very good question, Simon. You've actually preempted my next poll question. So, Kyle, maybe you can cue that. We'll put that up first in terms of, I'd be really interested to know, firstly, what you think is the useful life of a battery in a car? And then we'll come back and answer that. So if you can put that up, Kyle. And it is another really common question, thinking about the actual life of the battery. How often would you need to change it or upgrade it? What are the costs involved? Of course, with any new technology, when there's new components like this, it's number one on the consumer's mind. So we might...
Another 10 seconds.
Another 10 seconds.
All right. So it's quite interesting, actually. So the majority of people answered B, 750 kilometres, but it was quite closely followed by 34%, which is A.
Sorry, Kyle, could you just repeat that again for me?
Sure. So the majority of people voted for B, 750 kilometres, closely followed by A, 500 kilometre distance.
Right. I think the wrong question might have come up, but that's all right. We can answer that through. So that was for the bus, and in fact, for the bus, the world record at the moment stands at 1,000 kilometres, which is pretty amazing, really, when you think about it. But the interesting thing with the electric vehicles is that it's not really the technical limit so much as the economic limit. You can certainly have a bus or a car today on the current technology that could drive up to 1,000 kilometres or potentially further. It's just not economic to do so. If we come back to the question around the lifespan of the batteries, basically it does vary a little bit across chemistries and manufacturers in terms of how they design the batteries, but on average you're talking about somewhere between 10 to 15 years. And so realistically, a vehicle, average life is somewhere in that 15-year time span anyway. But the thing is that at the end of that, 10 to 15 years, that battery isn't actually dead. So whilst it may no longer, serve its use in a car, it may have dropped in this example from 500 to 350 kilometres, and it makes more sense to change it out. That battery can actually go in and be repurposed to be used as stationary storage. So if we actually look behind here, this is an example of stationary battery storage. This is the Tesla battery at UQ St Lucia. These are obviously brand new batteries, but essentially in the future, what we could be seeing is batteries coming out of electric vehicles at the end of that useful life and then put into this application for another 10 to 15 years. And that's really because in an electric vehicle, the amount of demand that's put on the actual battery cells is much higher than in a grid application. So it can suit that longer life. And then at the end of, let's say, that 25-year period, you can then recycle the battery. So somewhere around 95% of the battery could be recycled and turned into new cells. And that's going to be really important in the future to be able to help stabilize the supply of the valuable battery minerals and resources that go into making these vehicles, to be able to basically take them out, reuse them as a second life, as a battery powering a home or a building or the grid, and then be able to recycle them and turn them into new batteries. The other thing I wanted to talk about as well with charging is we only mentioned the slow charging. You can also generally, when you buy the vehicle, it either comes with or has the option to have a home charger. And so that can get it up to, maybe 50 to 60 kilometres an hour. And so realistically for most people, an hour top up a day is going to be more than enough to service your average needs. And then the really exciting part is where we're starting to see the advent of fast chargers. So in Brisbane, we're really lucky to be home to Tritium, which is a company that was founded by UQ graduates and now holds the second largest market share for fast charging hardware outside of China. So they're doing really amazing things over in Europe and also in the US. And more recently, through companies like EV Networks, we're seeing the deployment of this technology right across the country. So over the next few years, we will have national networks of fast chargers, and they can deliver about 350 kilowatts of energy. So what does that mean? You know, it's very hard moving away from the petrol, diesel kind of litre model to electricity. When we talk about kilowatts of power, if you're charging at 50 kilowatts, on average, you'll get about 50 kilometres every 10 minutes. So when we're talking about this technology that Tritium is building right here in Brisbane, it's about 350 kilometres of charge in 10 minutes. Now, there's no vehicle on the market that can currently accept that. This car here currently has the highest charging rate in the Australian market, and it's about 200 kilometres in 10 minutes. And we'll see when Porsche actually introduces their fully electric vehicle in the coming months, that will increase even higher beyond that. All right, so let's go back around to the front of the car.
Jake, just take another question if you wouldn't mind. There's a question regarding the glass roof,
Yes.
and it's from Michael. He says, what about the glass roof in a hot climate? How is the temperature inside the car affected?
Yeah, so that was another thing I was curious about. It's certainly, if you're a bit taller and your head is closer to the glass, you certainly do see some heat, but they particularly, it's a little bit hard to see in the light reflection, but that section that sits above the passengers and the driver is tinted. And so it does quite a reasonable job of reflecting the heat. I'd say it's probably not as good as a solid roof. Of course, some energy, some heat does pass through, but with these vehicles, because they can operate the air conditioning without an engine, without turning on, they're actually set up to be able to cool the car down if it heats up too much in the cabin. So in this, it's set at 30 to 40 degrees. If it gets too hot, the air conditioner will turn on and actually bring that temperature down before you come to the vehicle. So that's quite a nifty feature, which is unique to electric vehicles because they can turn off and on without that emission risk and potential health impact of it being inside and filling up your home with emissions. So we'll now come around to the front of the vehicle. So I'd like to now poll another question. I call this the oomph and grunt test. I'd be really curious to know what your thoughts are in terms of this list of vehicles that will come up on your screen in a moment. What is the fastest accelerating vehicle in that list of 0 to 100 kilometres?
Yeah, I've launched the poll, Jake, so we'll just give people 30 seconds to complete it.
Excellent. I call it the oomph and grunt test because I published an article in The Conversation last year talking about all of the potential oomph and grunt of electric vehicles. And we'll have a look in a second about what that oomph and grunt might look like under the hood. So whilst you're answering that, we'll actually show you, here's the app that you can control a lot of the features of the vehicle. And so I'm going to hit this button here, front. It's going to ask me, am I okay? And now the bonnet has popped, and we'll announce the results. We'll do a bit of a drum roll.
So the majority of people, 56%, went with B, the Tesla Model S Performance.
Yeah, so maybe that was a bit of an easy one, but yeah, in fact, that is correct. It is faster than this car by about 0.7 seconds. Not that anyone can tell. All of that list of cars is sub 3 seconds, but certainly in terms of that oomph and grunt, these cars in that initial acceleration, that being electric cars, have plenty of it. And so we'll see in a moment. You might know or might not know what's under the hood here, but here is my 8 V8s. A little bit of a practical joke, but a good demonstration of the extra space that you get in an electric vehicle, again, because the drivetrain is so compact. So the electric motor is sitting down underneath here. And again, in a lot of different models, it opens up this opportunity to store space. My favorite trick is when I go down to Coles or Woolies to pop the bonnet, put the groceries in and have a look around to see all the funny stares that people think I might be cooking the groceries. The other thing to note underneath here is coming back to that point around a maintenance. effectively, this cap is your main thing that you need to check on in terms of maintenance, and that's your windscreen wiper fluid. So it does, again, vary from manufacturer to manufacturer and even model to model. But with this particular car, when you buy it and you look in the servicing book, there are no specified normal servicing intervals. So you don't have to service the motors or the battery. Occasionally, there might be some errors that throw up, but what happens is that comes up on the dashboard in the vehicle, which we'll have a look at in a moment, and you then get a prompt to either take it into the service centre or you can call up the service helpline. And most electric vehicles now come with a SIM card, so that means they're fully connected and someone can dial in from anywhere in the world and be able to service the vehicle and hopefully, 8 out of 10 times, 9 out of 10 times, be able to diagnose and fix that issue remotely. So that's, again, another nifty feature of having that increased connectivity.
And Jake, where's the spare tyre if it's not in the boot or in the front?
Yeah, another good question. So it, again, varies a little bit, but most of them at the moment aren't coming with spare tyres. So the where tyre technology is at the moment in these new vehicles is that the chance of a puncture is far less significant compared to older vehicles. And so some of them do come with repair kits if there is an emergency, but a lot of them now aren't coming with spare tyres, and the actual incidence of those punctures are pretty minimal. So the other thing I wanted to point out is the cameras on this vehicle. So one topic that often comes up when we're talking about electric vehicles, but Tesla in particular, is the autonomous driving. What stage is the technology? How well does it perform? So firstly, if we think about the hardware, around the front of the vehicle, you've got a range of sensors and radar that are able to detect vehicles and objects around the car. You also have cameras. So you've got 3 cameras up the top of the windscreen here, and they are able to capture different distances up to about 250 meters. You've got another camera on the side here, a camera in the B pillar up here, and then a camera around the rear at the back. And so what this means is with these cameras right around the body of the vehicle, you effectively get a 360-degree view of everything that's going around. And so you're able to pull all of these images together along with the sensors that the radar is picking up, and be able to drive the vehicle in certain circumstances. Now, it's still very early days in the technology. There's a lot of work to be done, but particularly on highways, it's very impressive at the moment in terms of what the technology can do. It's still not legal to be able to hand over control of the vehicle. You have to remain in control of the vehicle. You remain responsible if anything happens, but that's the ongoing discussion at the moment. At what point will we be confident that we can hand over control to the technology and in turn hand over liability, which is the other major question. So we'll also, when we get in the car, have a look at what these cameras can do outside of just automated driving. And so the great thing is these cameras can be used as a dash cam. So if you're in an accident, you'll be able to get a photo or vision of the vehicle coming up behind, potentially sideswiping you and taking off. That's all captured and recorded on the vision. And also with your new car, if you're a little bit precious like me, when you go into the parking lot and you're worried about where you're going to leave it, the vehicle is recording constantly. And so if there's any damage or anyone comes along and opens their door into your car, that's actually captured to your footage. So we'll have a look at that in a moment, but I'll hand back to Kyle and he's going to cue a video that just gives you a bit of an overview of how the vehicle currently operates in this kind of semi-autonomous mode. I would have loved to have taken you out today in it, but it's a little bit difficult with the technology. So we've pre-recorded this session and we'll come back after that.
So let's first take a look at autopilot. Here's the car driving along the inner city bypass in autopilot mode, and you can tell this by the blue lines that are on either side of the vehicle. The vehicle itself is controlling the steering as well as the acceleration and braking. And you can see on the display, it's also picking up the vehicles that are in front, besides, and behind the car. This prompt just came up on the screen to remind me to put my hands on the steering wheel, and that happens on a regular basis. Another new feature is recognizing stop signs. So we can see here a stop sign besides the road, and this is picked up by the vehicle and shown on the display. Also recently, the vehicle's been able to recognize traffic lights. So the first example here approaches a set of traffic lights and are red, and you can see that shown on the display. In a second, we'll also see the vehicle pick up a cyclist ride across the vehicle right there. And then we'll fast forward this next section. The lights are still red, as you can note on the screen and in front of the vehicle. And in a second, they'll turn green, and that's also shown on the display. I've included just one more example of the traffic lights because it's quite a new feature and quite interesting. So again, we're driving along. We can see the vehicle cameras picking up vehicles in opposing traffic as well as in front and behind. You can actually use the display with your finger to look around and get a 3D view or map of those vehicles around. And again, we'll quickly fast forward. The lights are red in front, and in a short second they've just turned green, and that's shown on the display, and the vehicle then moves forward. Now these features are still in beta testing, but it's an exciting development of what the future might look like.
As you see, we've done a bit of a costume change and jumped into the vehicle now. But before we start to talk about this dashboard, have any questions come in about that video?
Yeah, they have, Jake. So it's from Saul. Do you think our roads will need to be modified so that the leap to full driverless can be taken?
Yeah, I think certainly line markings in particular are going to have to be improved to a great extent. So I've found in driving this vehicle as well as other electric vehicles with similar features that up until about Gympie, which for anyone that's not local is let's say 200 kilometres north of Brisbane. Up until that point, it's pretty good. The roads are reasonably new. Along those highway sections, they're well signed and marked. But after that point, it does start to get a little bit of haywire. The vehicle likes to have very clear lines in particular. And I think as well to move beyond the current stage. So generally when we talk about autonomous vehicles, it's on a 5 level scale, ranging from 1 being, very basic cruise control right up to 5, where there's no steering wheel, the vehicle drives itself. This is realistically somewhere between 2 or 3. For it to be level 3, you would have to be able to hand over control to the vehicle and hand over that responsibility in terms of what happens in an accident. So it's not quite there, but in those highway sections, when it is well marked, it is pretty good. So yes, that was a long way to coming to the point that I think we will have to upgrade infrastructure. And I think as soon as we start to see vehicles having vehicle-to-vehicle communication, being able to relay information to each other, as well as vehicle to infrastructure, where that infrastructure and cars are able to talk, that will also make quite a significant difference in terms of the amount of information that's provided to the vehicle. But if you would ask me a time frame, I think there's some very ambitious calls out there. We all know, particularly the CEO of Tesla has some very ambitious plans, but I think we're certainly going to be closer to 2030, if not into the 2030s, before we've really got a good handle on both the technological side as well as the policy and legal aspects. Any other ones, Kyle?
Yeah, so there's one here, you were talking about the cameras before. So are they standard RGB cameras? And is there any LiDAR technology on the vehicle?
So in terms of it, this vehicle doesn't have LiDAR, and that's a big debate going on across the industry. There's a group of companies that think LiDAR will be required to be fully autonomous, and that's because you get much further and greater vision from it. The challenge is that it is quite an expensive technology, and so it's difficult at the moment to see how that will scale down. You then have others, which the Tesla kind of camp falls into, which think that a vision-based system will be all that's necessary. So that's not necessarily my area of expertise. So I don't know from a technical standpoint which is going to be the winning strategy, you might say. But certainly we've got some way to go. In terms of the quality of the camera, maybe the best way is for us to actually pull up some vision. So what I can do here is I'm launching the dash cam. So this is actually, what I'll do is we'll go in and pick up recording here. So this is the camera's recording as the vehicle's been in a parking lot. I might just fast forward this so we can see it out somewhere, hopefully on a road. Someone getting into, okay, so now it's driving along. So that's the front vision. We can then see out the left. You've then got the right, the rear, and back to the front. So you can see the image quality is quite good. And this is what's being captured by all of those cameras at the same time as being used for those visualizations that you saw on the screen, and being able to help the vehicle, semi-autonomously drive in certain circumstances.
Jake, there's a question here on the session. So, how far away do you think we are from autonomous ride-sharing services, for example, Robotaxi?
So we're certainly seeing in the US some plans to introduce. Well, there's trials of those services at the moment, but on a more commercial basis, there's plans to do it in the next few years. But again, they're going to be limited in where they operate, and I honestly think that we will see. It's very tricky because often we look at these things in a kind of silo isolation. We look at electric vehicles, we look at automation, we look at vehicle sharing, but we've got to kind of look right across the spectrum of all of these changes to get an understanding of what might happen. And I think somewhere in that 10 to 20 year time frame, we're going to see a shift away from private vehicle ownership. I think people will still own vehicles, but far fewer than they do today. So they might be able to get down to just having one vehicle, and where that vehicle can be used might be restricted. So particularly in inner city areas, we're already seeing moves in Europe to ban certain petrol, diesel models from the city from an emissions standpoint. I think the next step will be that human drivers will likely be banned from CBD areas, and that's where we'll see the kind of robo-taxi take off. And of course, there's going to be some pushback to that, but ultimately, the reality is these vehicles are going to be so cheap to operate that I think the economics will win out in the end. If you can take one of these robo-taxis and it's a third or a quarter of the cost you're currently paying for a bus, that's going to make a significant difference. And that in of itself introduces a whole new, basket of problems, and something else we're looking at here at the university and trying to understand how do you strike that balance between encouraging the uptake of the technology, but not leading into, a potential nightmare scenario where everyone gets out of their bus, the train, active transport, and moves into their own little personal pods, filling up our streets. So it's not a straightforward technology will solve everything answer. We need to have a strong policy approach to be able to manage that transition.
And Jake, it's kind of a good segue, but regarding the vehicle recording, are there any privacy debates around the car recording all the time? Because obviously people walking past don't necessarily know they're being recorded, for example.
Yeah, so I mean, it's a relevant question for really all dash cam technology as well when you're driving along. I think it's something we certainly need to consider. The reality is when you look at the focus of the actual image, it's very close to the vehicle. So and generally, because the dash cam, the security feature it's an added bonus. They've not angled the cameras to necessarily capture that. The primary purpose of those cameras is for the driving assistance package. You do have the cameras focusing more on the road surface. So I think, in my opinion, whilst we need to consider those privacy concerns at the current state, it's not too big an issue because of where the cameras are focused. But that said, it might be something that we need to consider in terms of having some guidance around ensuring that remains the case and it doesn't get exploited for other purposes. You can see, there's certainly a debate going on about vehicle companies, manufacturers getting all of this data and what they might do with it. There's been a number of notable cases where people have tried to claim that they weren't at fault in doing some damage to a vehicle, not another vehicle, but the vehicle itself. Let's say you accidentally reverse into a pole or into a wall and people have claimed, oh, it wasn't me, it was the car. And all of that data was stored. So it was very easy for the manufacturer to go, well, hang on a second, we've got this all recorded. We've got all of the vehicle sensors and their movements recorded. We can clearly see that a human caused this problem. So that element is something that's under review. And there's pros and cons. That means that ultimately the warranty costs of vehicles go down because there's less frivolous claims. On the other hand, people may be uncomfortable with that. So that's something more specific to Tesla at the moment, but we are seeing increasing interest across the industry to kind of go in that direction. So it is something else for us to consider. And I would say that is a little bit independent to electric vehicles. We're seeing that right across the market. So yeah. So we might, I'll just quickly, we're getting a little bit late on time, but I'll just quickly wrap up so you have a chance to see some of the more, the features of this car. As you can see, this is quite a Spartan, minimalist dashboard. You literally have this large iPad controlling everything with the vehicle. These are the two main buttons. They have multi-function, so the function that works, in this case it's volume, but it depends on what application you have on the screen. You can use these to control the mirror, the steering wheel location. When you're in automated or semi-automated driving, you can control the distance behind another car, the speed you're traveling, all of those features. But besides that, everything is through the screen. So in terms of aircon, you hit a button here and you can again notice that there's no actual physical vent. So you drag on the screen to be able to locate where you want the air to flow. There's also some interesting modes. Dog mode, I wouldn't recommend it, but it's there if you were to go into the shops quickly and have a dog in the car, the air conditioning would continue running and something comes up on the screen saying, don't worry, my owner has left the aircon on. I still don't think it's a great idea, but it's a feature. The other thing is camping mode. So you can actually set up this car, sleep in it and have the air conditioning run overnight, look out the glass roof at the stars and wake up nice and refreshed the next morning to move on to your next destination. The other thing is obviously this map. So it's very similar, a Google map, which you can navigate to different places. Go in here, I want to go to the supercharger to charge up. and it comes up, and as you go along, it gives you all of your directions on the screen. In terms of actual settings, we'll just get out of that. You then got this menu, and through this menu, you basically can customize all of the different features in terms of the lights, the display. There's different settings in terms of the driving, whether you want chill acceleration or sporting acceleration, the steering mode, even the degree of regenerative braking. So lots of different features in here. And the other quick thing just to note is, again, like I mentioned, this car has its own SIM card. So you can even watch Netflix or YouTube whilst you're in the car, possibly waiting for a charge, or you can play games. So there's all of these particularly retro games in here that you can pull up on the screen. You can even get a USB controller and play 2-player games, which is quite funny and a different feature again. So yeah, that's pretty much everything that I wanted to go through today. I know that we're almost at the end of the session, but I might come back to you, Kyle, and see if we have any other questions. We're just going to jump out of the car, so just bear with us for a moment.
Yeah, thanks, Jake. We do have a number of questions. We're definitely not going to be able to get through all of them, but I might just select a couple. So this is a really good one from Oliver. Is redesigning the power grid for bidirectional power flow going to be a major bottleneck for electric vehicle uptake that needs to be looked into earlier rather than later, do you think?
So I don't think it's going to be a bottleneck in terms of bi-directional charging. I think, I'm not expecting that every vehicle we see will have that feature, but there will be a segment of the fleet that does it. To give you an idea of the scale, we've got 14 million cars in Australia. If all of them were electric and had, pretty low driving range, 250 kilometres, the whole fleet would be enough to power the entire country for 24 hours and still meet the mobility demand of the fleet. So there's enormous potential there, but I don't think we're going to have the entire fleet powering the country. So there will be a need for changes in regulations and for utilities to understand how these vehicles interact with the grid. I would say the more important component is what we call smart charging more broadly, and that's having some kind of control or some kind of price signal that encourages charging to take place outside of those peak periods. When we think about electric vehicles, you could have the entire car fleet go electric and it would probably only increase the electricity consumption by about 15%. Now, 15% is significant, but it's something manageable. We already have 20% renewables, so it's something that can be done. What's more important is not the amount of energy, but the rate of energy and when that rate of energy is applied. So we actually need to look at electric vehicles as an opportunity to stabilize the overall grid, smoothen out that profile, absorb more renewable energy. And a lot of that can be done through smart technology controlling the charging. So it's not to say that there won't be some grid upgrades required, but that that need can be mitigated to some extent and managed by incorporating smart technology. And so that's a big part of the Advanced Queensland project I'm doing, not focusing so much on the technical side, but the consumer side. There's a lot of evidence out there in terms of how the technology will work. What I think is still a bit of a missing piece is to understand what people like yourself would be willing to accept, how much you might be wanting to get paid in order to opt into such a program, or what sort of discount you'd require. So things are a little bit complicated at the moment to do that research with COVID and everything disrupted, but we're hoping next year to go out to market with some surveys and focus group work to get some data in on that.
Yeah, just another question, Jake. What are you aware of the numbers around Lifecycle GHG emissions between combustion and electric vehicles, including material procurement, production, use, and disposal?
Yeah, so it's a difficult one to put a single number on, because the emissions, particularly in manufacturing, vary very significantly depending on where the vehicle's made across the world and what the energy supply is. We are seeing a lot of battery manufacturers and electric vehicle manufacturers move towards renewable energy. And in fact, we've seen Nissan and BMW use recycled or second-hand electric vehicle batteries out of their vehicles to power their factories that are building new vehicles. So again, it's a little bit difficult, but overall, in general, if you look across the world, you can still see that taking into account that full life cycle, at the moment, the electric vehicle will reduce emissions by somewhere in that 20 to 30%. That can be increased a lot more though, if you use renewable energy for operation and manufacturing. And the other important aspect, so if you look at studies, there'll be very varying results. The key thing to look at is, did they consider the disposal or second use of the battery? Quite often they say 10 years, the battery's over, it goes into landfill. And I think given the value that's in this battery, even after 10 to 15 years, that's not a realistic view. So the studies that take into account those batteries having a second life and then being recycling, that's where you get a major difference, because you've got to compare them in terms of how they can be used. The petrol car doesn't have that second life application. After 15 odd years, that's the end of its life. The battery in the electric vehicle, which is where the major manufacturing emissions are, that's where there's the potential to have that second life application and improve the sustainability. So tough one, but yeah, still a reduction and will improve in the future. And by all means, anyone that wants to have more discussion about that, please send me an email. I believe my details will be going out after this session, and be more than happy to talk about it. So we're a little bit over time, so I'm just going to wrap everything up now. Thank you so much again for taking the time to be with us today at the University of Queensland. I hope you've had as much fun as I have, and I'm really looking forward to hopefully reaching out to many of you in the near future and having more discussions about electric vehicles. So thanks again, take care and enjoy the rest of your day. I'll hand you back now to Kyle.
Thank you, Jake. Thanks very much. And a big thank you to everyone for participating today. We hope you found the session interesting and have been able to take away some useful and practical information. This webinar is the first of a series that we're delivering over the coming months, featuring leading researchers, industry and alumni presented by our schools of civil engineering, chemical engineering, information technology and electrical engineering, and mechanical and mining engineering, covering a range of interesting and informative topics. The next event will be presented by our School of Chemical Engineering's Associate Professor Maureen Hassel, who will be discussing managing major disruptive risks, which is happening on the 28th of May at 10 a.m. If you'd like to keep up with the latest news and opportunities, to connect via our social media pages and website, the details are on the screen there. And as Jake mentioned, if you have any further questions, apologies we didn't get through all of them today. But if you do have more questions about Jake's work or would like to discuss any of the other opportunities to work with us, we'll be sending a follow-up email in the next couple of days with all of our contact details, so you can get in touch with us then. Thanks again for everyone for participating. Stay safe, and we look forward to hosting you at an alumni and industry event again soon. Thanks again.